Hello and welcome to Mechanical Y. Here I have a stick. Now what's special about this stick is that it is 1 meter long. The meter is a common and often preferred unit of measuring length, especially in scientific reporting. It is even perceived as having some inherent scientific superiority, especially over something as unimaginably useless as an inch or a foot, right? Well, this brings us to the subject of this video. That is the surprising and somewhat unlikely history of the meter and how it's defined. Over time, the actual length of the meter has changed. The modern definition can be traced back to 1795, but the foundational thinking that led to the meter can be traced back much earlier. While people have been measuring length for as long as history can determine, we lacked a standard way of defining units. In other words, the units and the distances they covered varied from place to place, but this tended to be less of a problem when you had large ruling bodies that controlled vast areas, like the Roman Empire, which could standardize length measurements in territories within their influence. But with the fall of the Roman Empire and increased fragmentation of Europe over the following centuries, any unit standard began to diverge and vary from location to location. While in 1215 England, the Magna Carta decreed that there should be a universal unit of measure across the entire realm, this ended up not being realized in practice for some time. Around the 17th century, however, an increased pressure was found on scientific research and discovery, and it was in this period that many began to realize that there is a need for a standard system that is universally accepted. And this led to the first standard length as being defined by English clergyman and later bishop John Wilkins. Wilkins made two key observations that laid the foundation for the modern meter. First, he said that this standard had to be based on a natural phenomenon that anyone could observe and derive. Secondly, he said that this system ought to be based on a base 10 system of counting, also known as a decimal system. In other words, it would count by tens. He chose to define a universal length as the length of a pendulum that had a period of exactly 2 seconds. As history would have it, this definition was rather close to the modern definition of the meter. However, the term meter was still centuries away. The pendulum definition was a good start, but it did have problems. First of all, the length of the pendulum would change from place to place. Because Earth's gravity is not constant in all parts of the world, the length of the pendulum that had a period of exactly 2 seconds varied. There were attempts to pick a specific location where this length would be measured and standardized, but this proved cumbersome and also fraught with errors. This brings us to 1789 France. At this time, there were many different units of measure across France, with the common being the pied du roi, translated as the king's foot, which was remarkably close to the modern foot in the US customary system. And it was divided into smaller units the same way. The pied, as it was commonly abbreviated, was subdivided into 12 parts, which in turn were divided into 12 parts, and those in turn were divided into their own 12 parts again. But 1789 France was a special time. It was the start of the French Revolution and the end of the Age of Enlightenment, also known as the end of the Age of Reason. While marked with incredible violence, persecution, murder, and suffering, the French Revolution did provide the impetus for the emerging government to replace the system of measures. And like so many people in that time, the pied and similar units faced execution. Between 1789 and 1797, France began to decimalize units of measure, and in 1795, the meter was officially defined as 1/10,000,000th the distance between the North Pole and the equator in a line passing through Paris. This was the first official definition of what is now the modern meter. But surveying such a long distance proved to be a little difficult, thus making a distance based on the survey somewhat impractical. So in 1799, several sticks were commissioned, and the length of the various sticks were compared to survey results, and the stick that came closer to the definition of the meter was chosen to be the new definition of the standard. That stick was placed in a vault in the foundation of a building in France, and there it remained. Now that stick was a fancy stick. It was a bar made of platinum and manufactured as well as contemporary techniques allowed, but it was a stick nonetheless, and Wilkins' original idea of measuring units being based on natural phenomenon was dashed. However, France was not a stable place around this time. In 1812, the French Empire was restored, and under Napoleon Bonaparte, the pre-meter system of measure was also restored. But this system was now defined in terms of the meter. This lasted until 1837, long after Napoleon's death, when his resolution on measurements was revoked, and the 1799 standard was revived and it was used in France beginning in 1840. Around this time, other countries began to use the meter as well. This was largely due to France's imperial expansion during that era. In the United States, for instance, the meter found use as a result of French influences in the Louisiana Territory. However, since the official definition was still based on a stick, only approximations of the meter could be found. To help mitigate this problem, a number of copies of that stick were produced. But these were prone to wear and damage over time, and inaccuracies in the international definitions remained. In a twist, the United States, the meter was actually defined in terms of the inch, rather than the other way around as it is today. And similar definitions of the meter were found in England and Germany, where the imperial foot and the Fuß, which is German for foot, were still being used. These countries didn't really want to use the meter, but France was a powerful country at the time. And in the 1860s, there was mounting pressure to adopt the French standard of measurements. This led to a conference being called, in France of course. This conference, held in 1875, led to the Treaty of the Meter. 17 nations signed on to recognize, amongst other measures, the meter as a standard unit of length. However, the actual definition of the meter was still problematic. So in 1889, a new conference was held. Known as the General Conference on Weights and Measures, it was attended by many nations, and they redefined the length of a meter as the length of another stick. Yes, this was a fancy stick made of platinum and iridium, and yes, precise copies were made of that stick, and the deviations from the original were measured, and these copy sticks were handed out to many nations, including the United States, but ultimately the meter was still defined by a stick kept in a vault in France. And as before, there were issues with the stick, such as the length would change depending on how you measured it. So in 1927, the definition was refined such that the length of the stick was measured while resting on two rollers at precisely the temperature of the melting point of ice. This may be much more scientific, but it was still ultimately arbitrary. It was far from Wilkins' suggestion that a unit of measure ought to be defined by a natural phenomenon. However, hope was in sight. The first half of the 20th century saw great advancements in physics, and it was found that a particular transition of krypton-86 atoms had a wavelength of 1,650,793.73 of a meter as defined by that stick. Another conference was held in 1960, and the definition was made. Flipping the measurements of the krypton-86 wavelength, a meter was now defined as the length of 1,650,763.73 wavelengths of krypton-86 in a particular transition state. Finally, the meter was defined in terms of a natural phenomenon. But why 1,650,763.73 wavelengths? Because that made the stick in France exactly equal to 1 meter. But as usual, there were problems with this method. So after a painfully long process spanning over 3 centuries, a new and now final definition of the meter was created. The meter was defined in a conference in 1983 as being the length traveled by light in a vacuum in 1/299,792,458th of a second. Why 299,792,458? Because in 1975, we measured light to travel that distance in 1 second using the previous definition of the meter, which was based on the transition state of krypton, which was based on a stick. But stick doesn't matter anymore. Here I have a meter, whose length we can always define by observing a natural phenomenon. And furthermore, prefixes defining multiples of this meter are based in the decimal system. John Wilkins could finally be proud. Now we can define a meter. All we need to know is how far light travels in a vacuum in 1 second. And we all know that 1 second is conveniently defined as the duration of 9,192,631,770 periods of radiation corresponding to the transition of the 2 hyperfine levels of the ground state of the cesium-133 atom. But why that whole definition is actually a whole nother story. Here I have a meter, with ancestors in antiquity, born out of the hatred of everything that was old in the cauldron of the French Revolution, made popular internationally through the imperial might of France and its political influences, and finally rooted in physics in the 20th century according to John Wilkins' original vision, the meter. Thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content.